Okay, so let's see how we get to grips with this. If you think back to those ideas of let's go back actually. So a staff object at the bottom of the slide, a staff object is a type of user, which is a type of person, or a student object is a type of user, which is a type of person. Think about those relationships. We replace all of our is a type of with inherits from. So a staff object inherits from user, which inherits from person. So if I write something for the person class, then that will then get inherited by the user class and then inherited by the staff class. So I only have to write it once. Same for the student. So what I just said in the bottom bullet point, if we write some code for the person class, all the other classes inherit that from that class, then all the other classes can use that code. That's the idea behind this, as a programming paradigm. So we also have some other terminology that we use. We say that a class which inherits from another is known as a child class, or sometimes a subclass. And a class that is inherited from is therefore a parent class or a superclass. So you can think about this like a family tree. You can think about this stack of classes, one inheriting from another one. Like you think about in real life, parents and children inherit facets of their parents. And we can even draw class diagrams to show what inherits from where. So typically you use upwards pointing arrows to represent inheritance. So here's my my class diagram for those classes. So the person is the superclass at the top. The parent, the grandparent, you could even think about it. The person is the superclass, and then the user inherits from the parent or the superclass. So the user is a subclass of the person, and then the staff and the student inherit from the user. So staff and student are subclasses or child classes of the user class. Okay, and that's it. As you can see, it looks a bit like a family tree as well. And there we can draw those relationships using arrows. And actually, in itself, that doesn't really tell us very much, that diagram. It sort of shows us what might be inherited, but it doesn't tell us what might be inherited. It doesn't tell us what actually is inherited. So if we include the attributes that live in those classes, so the data or methods that live in those classes, they can be really useful to tell us what's available. So this is what's called the UML diagram. It's a universal modeling language. You may have come across that in other places, particularly for databases. And you can see it's the same as my class diagram. So I've got the person, the user, the staff and the student, but it's also showing me all the attributes that are stored in each class. So the person stores the name, the user stores the user ID, the staff stores the job and the modules and so on. Okay, so a particular class, it stores all its attributes and those of the classes it inherits from. So for example, if we look at the student class, suppose I want to know what's stored inside the student class, I can immediately see, well, it's got the program, it's got the modules, it's also got the user ID because it inherits that from the user class, and it's got the name because it inherits that from the person class. So all those things are available in the student class for us to use to store data. But the student class, I only have to write these two in. I only have to create these two. Okay. And as I said, this type of diagram is known as universal modeling language, and it's universal because it's not just applied to object-oriented programming, but that's where you often come across it. It's also applied to databases, and you may have met it in database terminology. Okay, let's finish the video there and then go a bit into some examples.